we know how endothelin may mediate vascular damaging effects in diabetes.
Endothelin, as we know, is a very potent vasoconstrictor that also has effects on inflammation and vascular smooth muscle cell growth, which might play a role in vascular remodeling. Now, in diabetes, we know that the cause of death in large part is due to microvascular and macrovascular injury. And it's increasingly being demonstrated that perhaps endothelin plays an important role in this process. And one of the molecular processes or mechanisms whereby endothelin causes damage of vessels is through oxidative stress. And oxidative stress is defined as an increase in the bioavailability of reactive oxygen species.
Are there strategies to prevent damaging effects of oxidative stress by targeting endothelin?
Well, one strategy would be to use an endothelin receptor blocker, because if you block endothelin receptors, you'll block the effects on the activation of the NOxes and the production of oxidative stress. So it has been shown in preclinical studies and experimental models that endothelin can induce the generation of reactive oxygen species through its ATA receptor, especially in the vascular smooth muscle cells. So we know if we target the endothelin receptors, and specifically the ETA receptor, at the level of the vascular smooth muscle cells, this will result in a decrease in the production of the injurious reactive oxygen species such as superoxide anion. It's also being increasingly appreciated that the source or the enzyme responsible for the production of reactive oxygen species in the vasculature in the context of diabetes is most likely through the family of NADPH oxidases, also called NOxes. And there's been some very exciting work recently to show that endothelin, in association with diabetes or hyperglycemia or dyslipidemia, may actually induce an activation of NOx1, for example, and NOx1 activation in turn produces superoxide. And superoxide is very damaging to the cells. Also, there are non-pharmacological approaches that may also be beneficial. For example, we know that exercise, weight loss, a healthy diet does result in a healthier endothelium and a healthy vasculature, and part of this effect may be due to a reduction in oxidative stress.
Are there information on how different endothelin receptors may influence oxidative stress?
Yes, indeed. In fact, at the level of the endothelium, we know that the ETB receptor is associated with vasodilatory properties induced by endothelium-dependent mechanisms through nitric oxide. And we also know that nitric oxide is part of the reactive oxygen species machinery associated with oxidative stress. So if there's a decrease in the production of nitric oxide, maybe through decreased ETB receptor signaling, this may be a factor that contributes to vascular injury. On the other hand, an upregulation of the ETA receptors at the level of the vascular smooth muscle cells may induce activation of enzymes such as the NOxes that produce reactive oxygen species. So therefore, by targeting ETA receptors specifically in the vascular smooth muscle cells, for example, will reduce oxidative stress in the vascular wall, and perhaps by upregulating antioxidant genes in the endothelium or activating the ETB receptor will result in an increase in bioavailability of nitric oxide to preserve endothelial function.